We're on to another section on solving equations. And as we go through more and more, we're going to add little layers of complexity each time. But one thing that's not going to change is what it means to solve an equation. See if you can remember what I keep saying. What does it mean to solve an equation? Pause and see if you can answer that. It means find the value of the variable that makes the equation true. Find the value of the variable that makes the equation true. Okay, so what we're going to see here are equations that take multiple steps to solve. They're going to be a little more complex. We might have things to do like adding and subtracting from both sides of the equation. And then we might have a coefficient to deal with. Sometimes we'll have some like terms to combine along the way. We might have to distribute. So we're just adding layers of complexity. So the first one we'll look at is solve 6x plus 5 equals 23. Not too complex. We always start, here's the equal sign. So what are some things you should notice? How many terms are there in this equation? 1, 2, 3, right? 1, 2, 3. 6x is a term, 5 is, and 23 is. How many of them have variables? Just this one, 1. How many don't have variables? 1, 2. So that's a really important point. You know you want your variable to always end up by itself. And so what you're trying to do is peel stuff away from it. And you usually work from the outside in when you're doing it like that. So we need to get rid of something. We got two terms over here. The x term is going to stay for now, and it's this term that has to go. If we get rid of this 5, it leaves this 6x all by itself as a term, and that's what we want to get to. So we do the opposite. We subtract. Subtract 5 from both sides. Doing that turns this to 0, which is what we want, and leaves us with 6x equals 23 minus 5 is 18. Now we get to a very familiar spot where we have a coefficient number times a variable equals a number. We like it when we get there because then we always divide by that coefficient. We want it to cancel to be 1. 6 divided by 6 is 1, and 1x is equal to x. So we have x equals 18 divided by 6 is 3. And does that make it true? 3, if we put it back in here, 6 times 3 is 18, plus 5 is 23. True. Next, 3x plus 4x minus 2 equals 5. Pause, try it yourself. So, find the equation, the equal sign. There it is. Oh, we've got a lot of stuff over on the left. 3 terms on the left. 1, 2, 3, 1 on the right. 2 terms on the left have x's, and we have a constant on each side. When like terms are on the same side, this is important. When like terms are on the same side, we just combine them. If they're on the same side, like these two are, we just combine them. We simplify. Bring everything else down. Only do one thing at a time. When your like terms are on the opposite sides of the equal sign, like the 2 and the 5, we do the opposite. We want to do something to turn this into 0. Add 2. If it's minus 2, we're going to add 2 to get it up to 0. Add 2. 7x is still here. This becomes 0, right? 7x is still here. Equals 5 plus 2 is 7. And again, we get to a very familiar happy spot where we have a coefficient and an x. We divide by that coefficient, and we're left with the value of the variable. X equals 1. And we can go back and check that. Back up in here. 3 times 1 plus 4 times 1. 7. 7 minus 2 is 5. Let's do another one. Let's keep adding a little bit of complexity to it. 3 parentheses x plus 2, close those parentheses, equals We have negative 2 in parentheses times 5 in parentheses. Pause it, try it. So whenever we see parentheses, it should be a little bit of a, I don't know, just something, an alert should go off in our brains. There might be something I need to simplify here. The parentheses in this problem mean multiple things though. On this side, we have x plus 2 inside. So we have 2 terms inside and 1 term outside. That always should mean distribute. 3x plus 6. 3 times x, 3 times 2. Equals. These parentheses are only holding one single value, but they're next to each other. So what does that mean? Multiply. Negative 2 times 5 is negative 10. And now it's starting to look like the previous problems. 3x plus 6 equals negative 10. I've got a variable term on this side, constant terms on opposite sides. So we want to get rid of this one, turn it to 0, right? Cancel it out, do the opposite. 3x stays here, equals negative 10 divided by, or minus 6, sorry, is negative 16. And then we divide by our coefficient. We like that move. Divide by 3, divide by 3. And this one you're going to run into the fact that it doesn't reduce or divide evenly. So negative 16/3, do not change this one to a decimal. This is a little moment of importance. When you have a fraction, if you divide it, like 16, negative 16 divided by 3, if it comes out to this decimal that just goes on and on and on forever repeats, you do not want to give your answer like that because you can't do it unless you round it. You don't want to say it's negative 5.3 or negative 5.33. In this case, always state it just as the improper fraction, negative 16/3. It's totally fine. If your answer comes out to a nice, neat decimal, like if you had divided and it would have done 4.35, then you can do it, right? If it's a terminating, ending decimal, it's fine. But if it's a repeater, use the fraction. Next, let's look at solving this one. 2 to the 3rd power times 3 equals x minus 6 minus 6x. Pause it, try it. Okay. So, there's a lot of stuff happening. On the left, we have some exponents, stuff to multiply. On the right, I've got 3 terms. 2 of them have variables. So, I'm going to work, I think I'm going to start over here, and I'm going to work on just simplifying all these numbers, right? Because I have multiple operations, but it's just numbers. So, I'll start with the exponent. There's no grouping symbol. 2 to the 3rd is 2 times 2 times 2, which is 8. And 8 times 3 is 24. So that takes care of that left side. Equals. So over here we have 3 terms. 1, 2, 3. Here's where people start to run into problems. You might be tempted to add 6x here. This, I'm going to do what's wrong. So this is wrong. Frowny face. Do not do this. Plus 6x plus 6x. This is a common mistake. The reason you can't do that is because you're adding 6x to both sides, or to the same side of the equation twice. What you did was you just added 12x to the problem. You can't do that. You didn't do it to both sides. No, we do not want to do that. Eliminate that. What we want to do is combine these like terms. They're like terms that are on the same side. What you can do is reverse the order of these 2 terms, x minus 6x minus 6, right? This minus stays in front of that 6. This minus stays in front of that 6x. And what that does is it gets our like terms next to each other. And that can be really nice. X minus 6x is actually negative 5x. And then this minus 6 comes on down. That's an easy spot to get tripped up. All right, we're getting there. So now I have 3 terms. I only have 1 variable term. It's here on the right. I have 2 constant terms on opposite sides. I always want to get things away from the variable first, and I want to get rid of additional terms first. So I'm going to leave the coefficient and add 6. Add 6. Now we can add 6 here because I'm doing it to the opposite side of the equation. 24 plus 6 is 30. There's my equal sign. Negative 5x is still there. This has canceled out to be 0. And we only have one more thing left to do. What is it? Here's my x. Here's my coefficient. Divide by the coefficient, even if it's negative. You can divide by a negative as well. In fact, you have to. You want positive x. 30 divided by negative 5 is negative 6 is equal to x. There's our solution for that one. Let's try one more. So this one is 5x plus 2, parentheses, 6 minus x, parentheses, equals 10. Okay, so I've got an equal sign right here, and there's only one term over here on the right. One term. I've got a lot of stuff over here. I have a term. I actually have what looks like distribution because I've got parenthesis, which groups two terms, and a number outside. So to me, that looks like where I want to start because I want to break down those parentheses. I can't open up this whole problem and work on it until those parentheses are gone. So let's distribute the 2. Bring down the 5x, and it's a plus, right? I'm distributing a positive 2. If this were a minus, it would be a little different. But we're distributing a positive 2. 2 times 6 is 12. 2 times minus x is minus 2x. Bring down the equals 10. Stop, examine our problem again. This is now kind of like the last one. Don't be tempted to do this. Plus 2x, plus 2x. What's the problem with that? Stuck them both on the same side, right? Don't do that. What we want to do is imagine the plus 12 were just not there. We would have 5x minus 2x. That's what we're going to do. Now you might prefer to switch them around like we've been doing to get the like terms next to each other. Also notice what happened to my signs when I did that. Pause the video, take a look if you're not quite sure. The plus stays with the 12. The minus stays with the 2x. Now we can subtract these, combining like terms because they have the same variable. Subtract their coefficients. Bring down everything else. Oh, this is starting to look familiar. A variable term, a constant term equals a constant term. We know what to do. We subtract 12. We subtract 12 because we want this to become 0. We do the opposite. 3x is still here. 3x equals 10 minus 12 is negative 2. And finally, we divide by our coefficient. That's often the last thing that you do in solving a lot of these equations. Divide by that coefficient to get 1 in front of your x. X equals, again, this is a case where we just give the fraction. X equals negative 2/3. That would give us a repeating decimal. So there, lots of different looks to those different equations. Lots of things, distribution. Just always pause to examine the whole equation before you dive in. Get a plan, set it, and then work through it step by step.